Solar eclipse distribution. Why some places see more totality than others. The timing of solar eclipses is a matter of celestial mechanics and orbital cycles. Some places on Earth see total solar eclipses with relative frequency, while others might go centuries, even millennia, without one. This isn't random. It's a consequence of how the Earth, Moon, and Sun align over long periods. The uneven distribution of darkness, for example. Jerusalem last experienced a total solar eclipse in 1153 and won't see another until 2240, a gap of over 1,100 years. Meanwhile, areas in Illinois, Missouri, and Kentucky have seen two totalities in just under 7 years. This disparity stems from complex orbital patterns that determine where the moon's shadow falls on the Earth. The question isn't just how often eclipses occur, but where they occur. A long history of calculation, the average interval between total solar eclipses at any given location was once thought to be 360 years, based on a 1926 textbook. However, Belgian astronomer Jean Meus refined this figure in 1982 to 375 years, using early computer calculations. Recent studies, leveraging modern computing power, have confirmed this range, with the latest estimates hovering around 373 years. These calculations aren't just academic. They help predict future eclipse paths and understand long-term celestial trends. NASA's 5,000-year heat map, NASA's Scientific Visualization Studio, created a heat map covering 5,000 years, 2000 BC to 3000 CE, showing total solar eclipse paths. The map reveals that every location on Earth has experienced at least one total solar eclipse in this period, with most locations seeing between 1 and 35. This confirms that eclipses aren't exclusive to specific regions. They are a global phenomenon, though unevenly distributed in time. The latitude effect and orbital cycles. Recent research highlights the latitude effect, where solar eclipses are more frequent near the Arctic and Antarctic circles due to the Sun's low horizon path during certain seasons. The Earth's slightly elliptical orbit also plays a role. Total eclipses are more common in summer in the northern hemisphere because the Earth is furthest from the Sun, aphelion, at that time, making the Sun appear smaller in the sky. However, this advantage shifts over a 21,000-year cycle. In roughly 4,500 years, aphelion will coincide with the equinoxes, neutralizing this hemispheric bias. Another 5,000 years after that, the southern hemisphere will gain the upper hand. This long-term cycle explains why eclipse intervals vary widely over human timescales. Annular eclipses. A more frequent phenomenon, annular solar eclipses, where the moon is too far away to completely cover the sun, occur more frequently, about once every 224 to 226 years at any given location. This is because the sun is generally larger than the moon when viewed from Earth. In conclusion, the distribution of solar eclipses is not random, but governed by orbital mechanics and long-term cycles. While some places endure centuries-long waits, others enjoy regular totality. Understanding these patterns requires detailed calculations and a long-term perspective on celestial events.